All right, section 1.1 is all about rational numbers. But a couple things before we start with that. You should have a copy of these the divisibility rules at the top of your notes. So this should be in your spiral. If you don't have it for some reason, then it's online. You can just Google divisibility rules and it's in there. But it doesn't need to be this large. For some reason I ended up with a big one, but this is something that you should know well. So quickly let's go through this, because when you deal with rational numbers, you're going to have to do some dividing, and without understanding these rules, it's a lot more work. I think this rule here, if the last digit is even, then you know the number is divisible by 2. That one you should already know. So that's a given. And then if the last digit is 0 or 5, you probably already know that one as well. That means the number is divisible by 5. So the number out here on the left, this is the number that you want to divide by, and then the rules to the right. If the last digit is 0, you can divide by 10, so that one you should already know. Now the ones that are really useful are the rule for 3. If you add up all 3 digits in the number, so for example, if your number is 315, if I add 5 and 1 and 3, I get a 9. If that number, the 9, is divisible by 3, then the whole number, in this case 315, is also divisible by 3. So this number here, 139, if I added the 9, the 3, and the 1, I get 13, and 13 is not divisible by 3, so neither is 139. So you should know this one, and the divisibility rule for 9 is also pretty easy because it works the same way as the rule for 3. If you add up the digits and the sum is divisible by 9, then the whole number is divisible by 9. So 7 plus 1 is 9. Of course, you can divide 9 by 9, so you can also divide 711 by 9. So this one's kind of a given anyway. And then I would know the 4 as well, because if you just look at the last 2 digits, and those 2 are divisible by 4, the whole number is divisible by 4. So it's a pretty easy way to look at a number and be able to tell. 18 is not divisible by 4, so neither is 7,518. All right, so you should know 3, 4, and 9 as well as 2, 5, and 10. Now, getting on to the actual section, section 1.1 is all about rational numbers, and we're going to back up though before we start and look at the bigger picture, because let's see where rational numbers fall in terms of all the numbers. We need to start with the real numbers. And they're called real numbers because there is another category of numbers called imaginary numbers. So these numbers are real, and the real numbers would be, that's not exactly straight, but let's go with it. Any number that can be plotted on a number line is a real number. So now the ones that I've labeled are the integers, but of course there's numbers between them. So if I have this, for example, 0.5, that's on there, that's a real number. I could have -1.5. A mixed number is a real number. Some things you might not think about. This is 3.4 repeating. That, believe it or not, can be plotted on the number line. That's a real number. I could even plot pi right in there. So strange to think about it, but pi is on there. These are all real numbers. And you can break the real numbers down into two groups. You have the rational numbers, and just like the word rational implies, rational numbers just, they kind of make sense. They're not really weird. As opposed to the irrational numbers, that's the other group. Irrational numbers are irrational. They're strange. They don't make a lot of sense. So, if you want to, let's go to rational first. So I'm going to write some down, examples, and then we'll define what makes a number rational. So -3 is a rational number. 0 is rational. 2/3 is rational. The square root of 4 is rational. -7 8/9. I could have 1.78992 is rational. -0.3 repeating. Those are all rational numbers. And if you don't see the pattern, it's this. They can be written as fractions. So let's take a look at that. -3, I could put that over a 1, which makes it a fraction. Same with the 0. Any whole number or integer you can put over a 1 to make it a fraction. 2/3 is already a fraction. Well, the square root of 4, that's really 2. And 2 over 1 is a fraction. This one is a mixed number. Now, if I just multiplied the 9 and the 7 and added the 8, I could make this improper, which would be a fraction. I could convert that to a fraction, although I'm not going to do it because it would take a while. And this weird repeating one is also a fraction. Now, and the way you denote a rational number is by P over Q. That stands for fraction. And don't forget that the fraction bar means divide. So P over Q means P divided by Q. Don't forget that. P divided by Q. Well, if rational numbers could be written as fractions, irrational numbers cannot be written as fractions. So the question is, what would a number like this look like? The one everybody thinks of is pi, because it goes on forever and it never repeats and it never terminates. So pi, but there's lots of numbers like pi. The square root of 2, well, there is no even square root of 2. This is actually a decimal that goes on forever and never repeats. -√6. Same thing, goes on forever, never repeats. Square root of 8. Any square root that doesn't have a nice even root is going to be irrational. So when I say can't be made into a fraction, it's a decimal, a non-repeating, and non-terminating Okay, that's going to run out. Terminating means it doesn't end. Decimal. But we'll get into irrational numbers in a different section. This is where we're going to focus right now. So now we have at least some idea of what a rational number is. This section deals with converting rational numbers between forms, so from fraction to decimal or decimal back to fraction. So let's start with the fraction to decimal route. And I'm almost out of room on my paper, but writing fractions as decimals. All right. Example 1. 15/40, which means 15 divided by 40. So what I would do is to remember how to set up your division box, take the fraction, and I just make the fraction bar into the box directly like that, and then put the top number on the inside. So 40 into 15 is really what you're trying to figure out. The other thing you could do, and I think I'm going to do it here, is first of all reduce your fraction. So 15/40, I can divide the top by 5 and the bottom by 5. So let's go ahead and do that. If I reduce this fraction, it's going to reduce to 3/8. Because 15 divided by 5 is 3 and 40 divided by 5 is 8. Now I'm dealing with smaller numbers, so let's go ahead and make the box. 8 into 3 doesn't work, so you have to add a decimal and a 0. 8 into 30, well, 4 times 8 is 32, so I have to go 3, 24. Subtract those. I get a 6. Now, I don't have a remainder of 0, so I need to annex another 0. And I'm going to bring this 0 straight down. 8 into 60 goes 7 times, which is 56. That's going to give me 4. Still, I don't have a 0 remainder, so I need to annex another 0. 8 goes into 45 times. Make sure you line up your numbers directly over the digit that you're dealing with. And so 8 times 5 is 40. 0 remainder, bring your decimal straight up. And this would be a 0. So we get 0.375 for that one. All right. Example 2. Would be, so if we have, let's say 10/18. First of all, I can reduce that. I can divide the top and bottom by 2. And I get 5/9. Go ahead and make your fraction bar or division bar. Put the 5 on the inside. 9 doesn't go into 5, but it goes into 50, so I have to add a 0 or a decimal and a 0. 9 times 5. Put the 5 over the last digit in the number. I'm looking at 9 going into 50, so I have to put the 5 over the 0, not the 5. I get 45, subtracting 5. 9 doesn't go into 5 again. This is starting to look familiar. So add a 0, bring it down, 9 times 5 is 45. And then I get another 5. And then I add a 0. And it keeps going and going. So now you see the pattern. 0.555. This is going to go on forever. So this is a repeating decimal. And the 5 is the digit that's repeating. So you're going to write the decimal as 0.5. Don't do this. Don't say, well, I've seen the pattern, let me just add a bar over the last number. And so sometimes what I see is, if you see the pattern here, people will just put it over one of the digits. Well, it starts repeating here, so you can't do that. You have to put it over the first 5. Or they'll go, put it over the last one. It's got to be over the first one. Okay, remember that's rational. And if you see this repeating decimal was a fraction, so those can be made into fractions. It's just kind of weird. Example 3. Let's do 7/20. Now, there's a couple ways you could do this one here. I'm just going to do it in the same way I've been doing the other ones. So let me just rewrite this so you can see 7/20. Make my division box, 7 inside. All right, 20 doesn't go into 7, add a decimal and a 0. Actually, I'm going to put that decimal up right off the bat. 20 times 3 is 60. I get 1, 0. Now I have to add a 0, bring it straight down, and 20 goes into 100 5 times. So I get 0.35 is my decimal. That's one way to do it, although there is a quicker way. If you notice that the denominator is a factor of 100. So I'm going to put if denom is a factor of 100. That means if the denominator can multiply evenly into 100, if there's some number I can multiply this to get to 100, then there's a shortcut. So I'm just going to rewrite this fraction as a fraction over 100. So then you just, well, 20 times 5 makes 100. Do the same to the numerator. Then I have to multiply that by 5, and I get 35 over 100. Well, this is 35 hundredths because that 5 is in the hundredths place. Right away, I can write that as 0.35. And that's easy. I'm going to run out of video here for a second. So let me do some other quick ones. If I have 2 100ths, you could try to reduce that and divide, but it's already over 100. This is 2 100ths. Put the 2 in the hundredths place. If I have 3/5, I can make this, or you could even just make it into, if the denominator is a factor of 100 or 10 or 100, because it's even easier with 10. 5 times 2 is 10. 3 times 2 is 6. That's 6/10. This is the tenths place. So that goes straight to 0.6. You don't have to make it 100. You can make it a 10 if you can't evenly. All right, I think I'm going to have to start a new video here.